Well, in this short video, very short, all we're going to do is talk about injective functions, or a function that is called an injection. It is injective, or F is an injection. The definition. Remember what injective means? It means one-to-one, and that's the phrase I use more frequently. And I usually write it for shorthand just like this, 1-1, one-to-one. The function f from a into b is injective, or one-to-one, if what? I know you know what it means, but could you actually write the definition in a nice, short, concise way? Well, let's draw a picture. Here's a, here's b, and here's our function f. Normally when I draw one-to-one functions, if I'm just jotting it down and I want to remind myself that it's one-to-one, I'll kind of draw like a parallel lines like this. Kind of showing that each point in A gets mapped to a point in B that nothing else gets mapped to. So this would be a nice picture of a one-to-one function. What would not be a nice one-to-one function, or would not even be a one-to-one function, I'll put G instead of F, would be if I have let me put a little C and D inside A, and we'll call this Y. We've got two different points in A mapped to the same point in B, the domain. This is not one-to-one. This one is not. And why is that? Well, let's see. That Y right there is equal to what? It's equal to F of C. But it's also equal to F of D. That's a problem because F of C is equal to F of D. They map to the same point. But C and D are different points. So one way we could state this definition, F is injective, if this is true, then C and D have to be the same point. So picture me just squeezing C and D into the same point. And that's how we get the definition. F of C equals F of D implies, so if this is true, that implies, the right arrow, that C is equal to D. So essentially that's saying if you're at this point, there's only one way to get there. There's only one point in A that this function will map to that point. So that's the definition. And I guess I should say, for every C and D in the domain A. Okay, that's the definition. And you're going to need to memorize that because before too long we're going to be proving whether or not functions are injective. All right, so let's draw a couple of pictures. Two functions. I'm intending to make this one look something like f of x equals x cubed. And this one, something like g of x equals x squared. One of these is injective, one of them is not. Let's see, which one's which? Well, this one is definitely injective. This is one-to-one. One way is, we'll talk about the horizontal line test in the next video. Actually, maybe I'll talk about it in this video. If you pick any value of the function, and by value I mean height of the function, say this height right here, well, you have to go over to the function. There's only one point on this function that has that value. Whatever this value is, f of x is equal to that value. And notice every single point, every single height, every single value of the function has only one x value that will get you to exactly to that height. This one is 1 to 1. This is an injective function. This one is not. If I actually is f of x or g of x equals x squared, then I can just go out to -2 and +2. And I get two values of x, -2 and +2, that give me the same height, the same value of the function. So f of 2 equals f of -2, right? Because the height would be 4 and this would be a 4, assuming this is the graph of x squared. But 2 is not equal to -2. So in order to disprove or to prove that a function is not injective, just find 2x values that map to the same height, and you're done. That would be your proof. Finding a counter example showing that it's not, like this one. All you need to do is say f of 2 equals f of -2, which is 4. Okay, I mentioned the horizontal line test, and I guess I can just do it right here. I think you all know what it is. The horizontal line test is, for a given function, you draw a horizontal line. You draw a horizontal line, and if the graph intersects that horizontal line more than once, then it's not a one-to-one function. That horizontal line hits the graph twice. Therefore, it is not a one-to-one function. This one, I can draw a horizontal line there, only one, only one, only one. Doesn't matter where I draw the horizontal line. If you can find a horizontal line anywhere that crosses the graph more than once, then it fails the horizontal line test, and it's not an injective function. If it passes the horizontal line test, it means there is no horizontal line that crosses it more than once, and it is injective. So I'll let you write that out, the horizontal line test. If any horizontal line crosses the graph at more than one point, it's not injective. It's not one-to-one. Otherwise, it is.